Hello, my name is Ardi and we are going to solve this problem. So the question is, suppose that the network in figure 3.4, so this is the figure, has the following parameters. IA is 1 milliampere, R1 is 12 kilo ohm, R2 is 6 kilo ohm, IB is 4 milliampere, and R3 is 6 kilo ohm. Let us determine all the node voltages and branch currents. So what is the node voltages? The node voltages is the voltage in each node here, V1, V2, and V3 here actually. Have this one. And then branch currents, okay, maybe let's use different color. Let's use yellow. So what is branch current? So branch currents is actually the current for each branch. So this one will be I1, and then I2, and then I3. We also have IA and IB, but they are given in the problem. So let's label this. So IA is flowing up here and eventually it will going to the right. So we will have IA here. And similarly, we also have IB going down like this. Good. And now let's label what is given by the problem. So IA is 1 milliampere. So let's label them 1 milliampere. And then IB is 4 milliampere. So we'll have 4 milliampere. And then what else is given? R1 is 12 kilo ohm. So we'll have this one is 12 kilo ohm. And then R2 is 6 kilo ohm. 6 kilo ohm. And then R3 is 6 kilo ohm. 6 kilo ohm. So we need to use nodal analysis, which is actually a KCL in all the nodes. So we have three nodes here, P1, P2, and P3. Node 1, node 2, and node 3. But then this is our ground. What is the ground meaning? The ground is where the voltage is equal to 0. So we know that P3 is equal to 0. Good. Now to use nodal analysis, we need to do KCL at node 1 and also KCL at node 2. So let's do exactly that. KCL at node 1. Okay, what does KCL say? KCL said that the sum of the current that goes in is equal to the sum of the currents that goes out. So we write it like this. The sum of the currents that goes in is equal to the sum of the currents that goes out. Okay, let's see the node 1 here. The only current that goes in is this IA here. So let's write IA there. IA, and that will equal to, here we will have I1, and then this here I will have I2. Okay, maybe that is not capital A but small letter A. Okay, so I will have IA, I2, and I1 and I2. IA is equal to I1 plus I2. Okay, let's plug what we know from here. So we know that IA is equal to 1 milliampere. So we'll have IA is equal to 1. And then I1 is this here, but we don't know it yet, right? But then we can use Ohm's law to calculate I1 here, which is this voltage here minus this voltage here. So the voltage between them, and then divided by the resistance between them. So we will have P1, okay, P1 minus P3 here divided by R1. Good. And that is I1. We still have I2, and similarly we can play the same game here. We have this P1 here, and then on the other nodes we will have P2, right? Because the current passed through this resistor here. So we'll have P1 where the current comes from, and then P2 where the current is going to. So we'll have P2 here. Good. And then divided by the resistance between them, which is R2 here. So we'll have R2. Good. Now let's plug what we know from here. So we will have 1, and then we will have P1 minus V3. We know that V3 is 0, okay, divided by R1. R1 is 12 kilo ohm. So we'll have 12, and then plus P1. P1, we don't know it yet. And then V2, what is V2? We don't know it yet too. So we'll have minus V2 divided by R2. R2 is 6 kilo ohm, so we'll have 6 here. Good. Now I want to get rid of all the denominator by multiplying both sides by 12 because they will cancel out each other, right? So 12 will cancel each other. 6 and 12 will cancel into 2. So on the left hand side, I will have 12 here, and that will equal to P1 minus 0 is just P1, but then 12 and 12 will cancel each other, so we will have P1 here. Good. And then 6 and 12 will cancel into 2, so we will have plus 2V1 and then minus V2. I mean 2V2 minus 2V2, right? Because we multiplied by 2. Good. V1 plus 2V1, there will be 3V1 and then minus 2V2, and that will equal to 12 here. I think nothing further that we can do. Let's save this as equation number 1. So from this first node here on P1, we get this equation here. But then we have 2 variables. We need 1 more variables to solve. Okay, let's save this equation number 1. Okay, let's clean up them first. Okay, so far we got this equation from the node number 1. And now let's do the other nodes here, which is KCL at node number 2. Let's play the same game again. So KCL said that the sum of the current that goes in will equal to the sum of the currents that goes out, right? And let's see here, the currents that goes into this node is only I2, right? So let's write that. So we will have I2 on the left hand side. Are there any other currents? I think no. So we will have only I2 that goes in. And then that will equal to this current here, IB. Okay. And then plus this current here, I3. Good. And now let's plug what we know. What is I2? Yeah, I2 we don't know it yet, but we can calculate it using Ohm's law like before, right? Because that is V1 and then this is V2. The current where it comes from is written first, so we will have V1, and then where the current goes, it's written here, so we'll have V1 minus V2 divided by the resistance between them, which is R2. Good. And now what is IB? IB is this 4 milliampere. So we know that IB is 4. Good. And then plus I3. I3 is this one here. So we know that it goes from V2 into here, this node here, which is V3. So we know that I3 is V2, where it comes from, and then V3 where it goes, divided by the resistance between them, which is R3. Good. Now let's plug in what we know. V1 we don't know it yet, V2 we don't know it yet. Let's just write it. V1 minus V2, then divided by R2. What is R2? R2 is 6 kilo ohm. So we'll have 6 here. And then that will equal to, this one is 4. And then we know that V2 is unknown. So we'll have V2 minus V3. V3 is 0. So we'll have minus 0 here divided by R3. R3 is 6. That's good. I want to get rid of that 6, so we multiply both sides by 6. Good. 6 and 6 will cancel each other, so we will have on the left hand side V1 minus V2. Good. Now 4 multiplied by 6, that will be 24. And then V2 minus 0 is just V2. But then 6 and 6 will cancel each other, so we will have V2 here. And let's move this V2 to the left hand side. So we'll have V1 minus 2V2 is equal to 24. Good. And I think let's save this as equation number 2. So we will have V1 and then minus 2V2, and that will equal to 24. Let's save this here as equation number 2. Okay, so the next step is we need to solve this equation. We should be able to solve it because we have 2 equations and 2 variables. Let's do that. Okay, what's next is we need to solve this equation, and we can do that by just subtracting here. So we'll have minus here. Why? Because minus 2V2 and minus 2V2 will cancel each other, right? So we will have 2V1 here because 3 minus 1 is 2. And this will cancel each other. And then 12 minus 24, that will be minus 12. And so we will have V1 here is equal to minus 6. And the unit will be in volt, right? Because we have the set of kilo ohm and milliampere. So this will be in volt. Okay, that is good. But then we can calculate V1, V2 from here, right? Let's substitute this into 2. So we will have V1 minus 2V2 is equal to 24. And we know that V1 is this one. So we'll have minus 6 minus 2V2 is equal to 24. And let's move this to the left hand side. So minus 6 minus 24 is equal to 2V2. Then minus 30 is equal to 2V2. And so V2 is equal to minus 15 volt. Good. And we answered the node voltages question. So V1 and V2 is all the node voltages, right? You know that V1 and V2 is the node voltages. So let's highlight that here with gray. So we know that that is the node voltages. Okay, but then we still need to find out the branch currents. Let's do that. What is I1 here? Okay, I1 is equal to, remember, V1 minus V3. V1 minus V3 divided by the resistance between them, which is R1. Okay, what is V1? V1, we know that is minus 6. And then V3 is 0. So I have minus 0 divided by R1, which is 12 kilo ohm. Minus 6 divided by 12, that will be minus 0.5. So we'll have I1 is equal to minus 0.5. And the unit will be in milliampere. Good. Now let's do that for I2. What is I2? I2 is V1 minus V2. V1 minus V2 divided by R2. Right? What is V1? V1 is minus 6. And then minus, what is V2? V2 is minus 15. So we'll have minus 15 here. And then divided by the resistance between them, R2, that will be 6 here. So we will have, what is this? Minus 6 plus 15, that will be 9. 9 divided by 6. We will have I2 here is equal to 1.5. And the unit will be in milliampere. Then what is I3? I3 is V2 minus V3 here divided by the resistance between them, which is R3. Good. What is V2? V2 is minus 15. And then minus V3. V3 is 0 because that is our ground. And then divided by R3, which is 6. So we will have minus 15 divided by 6. What is minus 15 divided by 6? Okay, that will be minus 2.5. So we'll have I3 is equal to minus 2.5 milliampere. So this is all the branch currents that is unknown from the circuit. I1, I2, and then I3. Let's highlight that yellow so that we know that that is the branch currents here. Okay, I think that's all for this example problem. Hopefully this will help you to understand nodal analysis. Thank you for watching. See you in the next video. Bye-bye.